Welcome to the Miss Maths. This is 11th standard limits. Very few questions are left out in exercise 12.1 and I think today all the questions in exercise 12.1 will be over. I have done each and every question in exercise 12.1. So we'll start. I hope you revised all that, whatever we have done, and you feel limit is the easiest of everything. Fine. Problem 29, 30, 31, 32 is our target today. Let's see problem 29. Let A1, A2, of course A3, A4 and so on up to AN be fixed real numbers. And define a function. Define a function fx which is equal to x minus a1, x minus a2, x minus an. Of course, so many brackets will be there. What is limit of fx when x tends to a1? For some a which is not equal to a1, a2, an, what will be the limit of fx x tending to a? Let a1, a2, an be fixed real numbers and define a function fx. X minus a1, x minus a2 and so on, x minus an. What is limit of fx? X tends to a1 for some a not equal to a1, a2, an. Find fx x tending to a. I think by now limits should be just a child's game to you. Not only limit, any branch of mathematics, a clear understanding we have, it's a child's game. We don't understand, of course, that's not interesting and we lose interest and it is very difficult. I'm sure all my viewers feel that maths is the most easy and it could be done wonderfully well and you're going to get the maximum marks. Okay, so we go with the first question. What is limit of fx x tending to a1? This is fx. So limit fx x tending to a1. That is, x will be replaced by a1. And if it's something that you can get the answer, that will be the answer. Your problem will come only when it takes some form which I say it's an indeterminate form. So this is equal to a1 minus a1. a1 minus a1 is 0. 0 into anything finite will be 0. So, limit fx x tending to a1 is 0. I hope you find it's a damn simple, damn easy and quite interesting. So, this is the answer for the first subdivision. Now, we go for second subdivision. We go for second subdivision. What does the second subdivision say? What is limit of fx x tending to a? A is not equal to a1 or a2 or an. If a is equal to a1 or a2 an, then we know it will become 0. So now fx is equal to x minus a1 x minus a2, x minus an. Limit fx x tending to a. So they put a for x, a minus a1, a minus a2, a minus an. So this will be the answer because this can't be simplified further, isn't it? So answer this. This is the answer. Honestly tell me, simple, easy, I can do it. Yeah, you will do it. I can score a mark. Yes, you will score marks. Now we go for the next one. This is problem number 29. Problem number fx is mod x plus 1 when x is less than 0. It is 0 when x is 0 and it is mod x minus 1 when x is greater than 0. So mod x is x when x is greater than 0. Of course, when it is equal to 0 also it is x only. So now fx is equal to mod x is less than 0. Mod x is x when x is greater than 0 and mod x is minus x when x is less than 0. So fx is minus x plus 1. When is it? When x is less than 0. And it is 0 when x equal to 0. And it is mod x minus 1 when x is greater than 0. Mod x when x is greater than 0 is x minus 1. This is x greater than 0. What does he ask you? For what values of a does fx exist where x tending to a? The questionable point is 0. So when x is less than 0, it is this, which will be 1. Limit will be always 1 when x is less than 0. And limit will be minus 1 when x is greater than 0 always. But the question is, what happens at 0? Limit fx x tending to less than 0. When it is less than 0, you will put 0 minus. 0 minus means it's less than 0. 0 minus means 0 minus a small quantity. That will become less than 0. So that is 1. Limit fx x tending to 0 plus. You have this 0 plus 0, that is minus 1. So right limit and left limit are different. Right limit and left limit are different. Limit will not exist. Limit will not exist for x equal to 0. Otherwise, limit will exist for everything. So what will be the values? Here anything, a can take any value except 0. So I repeat the answer. Putting the answer in an excellent way is a way to score marks very well, especially in an NCERT exam. A can take any value except 0. That's what you give us the answer. Now I go for the next question, problem number 31. Problem number 31. If fx is satisfying, limit x tends to 1, fx minus 1 by x square minus 1 is pi. What is limit of fx x tending to 1? So limit fx minus 1 by x square minus 1, x tending to 1 is pi. So I should find out limit of fx x tending to 1. Limit of a numerator by the denominator is limit of the numerator by limit of the denominator. So this will be limit fx minus 1 x tending to 1, that is equal to limit x square minus 1 x tending to 1 into pi. Now put 1 here. This is f1 minus 1. Put 1 here. 1 minus 1 0. Put 1 here. 1 minus 1 will be here 0. So you will have here x plus 1 into x minus 1 into pi you will have. Okay. So you are going to put x equal to 1. So this will become 0. When this becomes 0, what will be f1? f1 will be 1. I hope you understand this. I again repeat it. The limit of fx minus 1 by x square minus 1 is pi. Find limit of fx when x tending to 1. Limit fx minus 1 by x square minus 1 is pi. Limit of a numerator by denominator is limit of the numerator by limit of the denominator. So this will be limit fx minus 1 into, this will be crossing there, limit x square minus 1 into pi. Now put 1, when x tends to 1 it is 1. So f1 minus 1. This you put 1. 1 minus 1 will become 0. It is 0. So what will be F1? F1 will be 1. Okay. Now we go for the next one. If number changes here, accordingly we will have. Okay, fine. Now we go for the next one, 32 problem. If fx is nx square plus n, x is less than 0, nx plus m when x lies between 0 and 1, and nx cube plus m when x is greater than 1, for what integer m and n does limit fx x tending to 0 and limit fx x tending to 1 will exist? Suppose for this problem you have 5 here, accordingly it will go. You have 2 here, accordingly it will go. You have 3 here, accordingly it will go. Now we will go for this question now. Fx is mx square plus n x less than 0. Nx plus m when x lies between 0 and 1. And it is nx cube plus m, x is greater than 1. Now we will see this. Let's see what is going to be limit of fx x tending to 0. Little less than 0. You put like this, 0. Little less than 0 will be here. It is mx square plus n. This is little more than 0, nx plus n. So this limit will be 0, n. This limit will be 0, m. When will this limit exist? This limit will exist when n is equal to m. So this is the answer for limit fx x tending to 0. The limit will exist. The limit will exist if the integer m is equal to n. Next we go for same question. The last few minutes now. He is asking what will be fx when x tending to 1. It will exist. That limit is existing. We have to define what will be m and n. X tending to 1. Put 1 here. A little less than 1. A little more than 1. Limit of this will be m plus n. And limit of this will be n plus m. Both are equal. So limit will exist for what? For any m. Sorry. For any n and any n. Okay. So the limit x tending to 1 will exist for any n and for any m. So with this chapter is over. I think in the next video I'll explain to you what is derivative. I'll derive to you what is dy by dx, what's the meaning of dy by dx, and we'll go for the chapter derivatives. So practice all this. One complete chapter is over. You can even judge yourself by fixing a time and working all the problems in that. You fix a time. You fix half an hour or 45 minutes and you prepare that and work it so that will be a good practice for your exam. Best wishes. We will meet in the next video with derivatives.